Hey folks, Quilly18 here, and welcome to another Unity tutorial where we create a base building game as part of Project Porcupine. Right now, we have things set up such that we have some basic data structures here, and we have something called our world controller, which instantiates the world object, which then spawns 10,000 tiles. After the 10,000 tiles get spawned in memory, these are the data tiles, our world controller then creates 10,000 game objects and positions them in the correct place. They also have a sprite renderer. These things will represent visually our data tiles. Furthermore, every 2 seconds, the tiles in the game world, the data tiles, get randomized. They alternate between being empty space and having a floor there. Unfortunately, right now, there's nothing that is updating the sprite renderer on our tile game objects, and that's where we're at. We do have a function over here in the world controller called onTileTypeChange. This is what we want. We want this function to get called with the tile data and the correct game object, and we want, at that point, we'll update the sprite. This is all set up. We just need something that calls this. So in tile, we have the setter over here. This is how tile type gets changed, is this gets set, which is what happens in world. Every time a tile gets randomized, it's just going to tile.type, and it's giving it a type, which is calling this setter here, right? The value gets passed in, it gets stored in our internal protected variable of type, and then we move on. So we can call a callback here. So we want to call this function. How do we do it? We're going to use the action delegate. So delegates are sort of like, they're variables in C# that hold a reference to a function that can be called later. And action is just a handy shortcut for a delegate, because I find working with delegates kind of awkward. But defining actions, I don't know why, but action and func I really love. I don't know, all about that func. We do need to say using system. Well, we don't need to, but it's a hell of a lot more convenient. By doing this, that means we now have access to action. So if I just said action, some function, right? Some function like this. And then somewhere along the way, I did something like void, this is a function, blah, blah. What I can do is that variable, some function, I can set it to be called, this is a function. God damn it, why does it keep this? There we are, that was weird. This is no, not like that. I set it like this. So I'm not calling this as a function. I'm just storing the reference to this in there, and then later on I can call this like this, and what this will actually run is this bit, which is kind of cool. Not only that, but what if this required a variable? What if it had a parameter where it wanted some sort of integer called a? Well, that can also work, because I can tell it, my action, that it expects an integer. So this is an action that expects an integer as a parameter. And actually, I can expand this. It wants an integer and a string and a float. Right? Integer, string s, float f. That's fine. And then down here, I can say call function 123 blah and 1.23 f. There we go. And this will work fine. This calls this with those values. Very cool little thing. So what we can do, get rid of all this garbage. Sorry, I hope you weren't typing that along. My bad. What we can do is say, hey, listen, what if we had an action called, I don't know, tile type changed callback? We could also do something like CB tile type changed. I don't know what's like more convention or looks nicer or whatever. Like we had this action here, right? And then over here, we can call that. Whenever the tile type changes, we can call it. And then as long as something sets this somewhere, then it'll get called every time the value gets changed. Okay, well, let's work on that. Let's work on that. Now, this is just going to call a function. But this function isn't necessarily going to know which tile changed, right? This is a function that would get called when any tile gets changed, call this function. But we're not telling it which tile changed. So what if we change this to say, listen, this callback is going to expect a tile. And then we can call this. So now, all of a sudden, this is a function that will get this tile as a parameter. Ooh, now we're talking, right? Because if we look at the world controller, on tile type changed will want that tile data. It wants it. So we can, that's great. Now we're sending it that. It also, however, wants the game object. So it knows which game object's sprite renderer to update. Now that gets a little bit tricksy. What we could do in here is we could do something like that, like game object, my visual tile game object. We could have that information. It could get passed to us in some fashion over here. I don't like this because what this does is this makes our data layer have some sort of awareness of our visual layer, which we may not want. Heck, what if later someone decides to port this game to another game engine other than Unity? I mean, it would still need to be C# or whatever, but that game engine doesn't have game object. It has some other type of thing for its visuals. I want to keep this completely segregated. What if, here's another option. What if we end up with a situation where we have so many tiles and performance is a bit tough, so a game object tile that is not in the camera view, we're just going to destroy it and keep it out of the way. That way, the game object tiles don't exist if they're not in the camera view. Or what if we take the Dwarf Fortress route where we have multiple floors, right? Our space station can now grow tall vertically. You can go down into the basement or up into the upper floors and the penthouses and stuff like that. So clearly, in that case, we're not going to want the game object visual tiles of things of other floors. We only want the ones of the current floor we're on. So this might come and go. And then we have to pass it the game object every time we recreate it or destroy it. No, get rid of that. I don't want the data classes to have any awareness whatsoever about the visual stuff. So, okay, so it's only going to know it's got to call a function and pass itself to it. We're going to have to deal with that. This thing has to get set somehow. That's pretty easy for us to do. We'll make a public function, public void register tile type changed callback. It's a little wordy, but we'll deal with it. This is going to be a function of the form action, which will pass a tile, and it's going to call, I don't know, callback, something like that. And what we're going to do is we're going to set this to that. There we go. So someone can call this, pass it some sort of function, which we then store here, and that function will get called every time this happens. Okay? Hopefully that's okay. It's kind of interesting. This thing here, this action is kind of special. Well, first of all, it can be null, right? By default, it's a null, so we should actually check for that. If it's not equal to null, then we call it. That we do have to check. But here's the thing. You kind of, by this, you expect it to sort of just be like one function. You can actually, it's actually sort of secretly an array in a weird kind of way. If I do a plus minus over here, this means we can actually have multiple functions get called. I could a bunch of different subsystems could all decide to hook into this. And then when the tile type gets changed, 3 different functions get called. I literally have to do nothing else. This would actually call 3 separate functions, one after the other, I think in the order that they get registered, although don't quote me on that, certainly. We've got that. If you wanted to, you could also do an unregister. Unregister, again, requires a callback, and then you just go minus. That will find it in the array and remove it. I don't remember if it throws an error or not, if it's not in there. I guess we'll find out at some point. So, this can exist. We may not use this. I have no idea. But yeah, technically this will work. This will allow us to register a callback and unregister. So whenever the tile type changes, those functions will get called. Right now, that function can only get past the tile itself, which makes sense. There's going to be lots of things that plug in here and only want the tile. They don't care about the game object. But the tricksy part is this does. So here's what we would like to do at this point, right? We have got our tile data. What we want to do, our tile data, we want to register tile type changed callback. And we'd really love to do this. But the problem is, and if we pass over, it'll actually give us an error because the delegates don't match, right? It is expecting something that just requires a tile parameter, but it's getting something that requires a tile and a game object, right? Tile, and a game object. Whereas this is just expecting just purely a tile. this would work just fine if we had a function called foo, like this, that just wanted tile data. This would be totally legal. It's fine. See, this works just fine. But this doesn't help us. How do we get the link? We're going to use something called a lambda. This is some cool ass advanced mojo, but it's awesome. A lambda, which will require, I believe, using system. I'm not actually sure. Don't quote me on that. I suppose we can try it without, actually. Let's try it without and see what happens. A lambda is basically an anonymous function that you can just like make on the fly. So this is expecting a function that just requires one variable. That is a tile. This is an empty lambda. This is a lambda that does nothing. It's an empty function. It's the same as doing a function called void foo. That. Literally the same, except this function has a name called foo. This function has no name. This doesn't run instantly. It's just a function definition. It's not running. What we can also do is say, hey, this anonymous function has a tile here. Notice there's no type. And then it does something. So now we're talking about something that's more like this. These two are basically the same, except again, this is a function with no name. Right? So right now, these two lines are effectively the same. This line and this line, because foo exists like this. Imagine, if you will, foo can call another function, right? Foo could call onTileTypeChanged, pass a tile, and then some game object. Right? Foo can do this, except it doesn't have a game object. We know what the game object should be, though. It's this. This is the game object for the tile. So in here, in our function, which can do anything, 1 + 1, whatever, it's just a function. What if this called onTileTypeChanged with this tile, comma, tile game object. This is the tile game object right now. We're saying for this tile data, it's going to run an anonymous function. It gets past the tile, which is this. As it turns out, this tile here is literally the same as this tile. Like this is the same tile data. Literally the same. But we'll go ahead and do this. This needs a semicolon at the end, just like if it was in a function, but it gets this. So now let's get rid of this foo, and let's get rid of this. So the callback that gets called here, it's calling this anonymous function, this lambda, this anonymous function, and passing it a single tile. It's a single tile coming in here, and this is then going to call onTileTypeChange. OnTileTypeChange is not being called right here. Inside of this start, it's not being called right here. It's just inside of a function. When this function, this anonymous function gets run, then it gets called with this tile and the tile game object, which is pretty damn cool. And even though this start function ends, it ends over here, and you'd think everything in here gets cleaned up. So if everything in here gets cleaned up, like how does it keep this link between this tile go and this tile go? It's something called closure and things. We're not going to get into that. But this will work. How do we know? Let's freaking run it. Okay, no syntax errors. That's good. So let's hit play. Oh, we got tiles. Wait 2 seconds. Tiles randomized. Wait 2 seconds. Every 2 seconds, the tiles randomized. So here's what's happening, right? We create an empty world. Then we create a bunch of game objects for every tile. And we create this little link, this callback. And then we randomize the tiles. Randomized tile, all it does is it takes the tile.type and sets it to something. When a tile's type gets set, it runs a function here, which sends us back over to this anonymous function, which then runs this. And, so it's hard to kind of keep track of all the loops, but really, you've worked with Unity, you're used to this. OnTileTypeChanged, we get past a couple things. Okay, let's make sure to update the sprite. That's it. This little glue thing right over here ensures that this gets run. And this ends up, again, the first time you work with these lambdas, it can be a little confusing, but you actually end up writing very, very little code. The chance of an error in programming is directly related to how many lines of code you have. And even though this is slightly more complex than certain straightforward programming, it cuts back on the amount of code writing you have to do so dramatically that you actually get fewer errors. All you need to know is that whenever tile data gets changed, this function will get called. Because we told it what function to call, which is this, which then calls this. And there we go. It runs beautifully. We are not polling. We're not on every frame. We're not checking 10,000 tiles to see if anything changed. We only change a tile when this happens. Now, right now, it so happens actually that every 2 seconds, all 10,000 tiles are getting changed. I mean, because this isn't checking to see if it's already empty, right? And we can do a thing like that. Like, there's no reason over here we couldn't do something like tile type old type is equal to our current type over here, right? And then we can say something like if there's the callback's not null and old tile type isn't equal to the new type, right? So now all of a sudden this only gets run if the tile type literally changed, if it was empty and it's now a floor or vice versa. If I don't do that, technically this will get called if it wasn't empty and it's still an empty, or if it was a floor and got told to be a floor. I don't know. 6 of one, half a dozen the other. Should it get called if the tile type didn't actually change? I guess not. Right? Let's do this. It only gets called if the type actually changed for real. Which means now, this callback won't be called 10,000 times every time we randomize the tiles. It'll only get called for the tiles that actually do get modified, which is still, it's going to be about roughly half statistically. Which is good. All right, groovy. And I believe this should still work. Let's do a little test. And if you wanted, you could start running benchmarks about how fast these things go, but clearly they're going pretty damn fast. That one frame where they switch from one to the other might lead to a little bit of a dip. We actually lost a little bit of frame rate there just because I panned over to see more over here. If I zoom in, well, again, it's all v-synced, so it's actually, this count, the stat doesn't really make much sense. But you can compare like render thread and CPU time, and you can run the profiler. Right? The what I'm looking for. Help me out here, brain. Oh, profiler. It's already down here. La la. Profiler over here. So this does some debugging. So if I hit play, and it doesn't normally run if it's not on the screen, so you have to like have it up there. I think I might be lying actually. The record was on, and every 2 seconds. We see a little tick of stuff, presumably here. And if we analyze it, we can start to see where the bottleneck is. Right now, 95% of our CPU time is being spent doing the VSync. 95% of the time is just waiting for the next like hardware frame to come around. And then every now and again, there's a little bump in the road. Sometimes it's because of garbage collection. One of the things you want to avoid is ever creating a lot of instances of something and then having them be cleaned up. And that is actually one of the things over here. We're creating, this is only an enum, which is very small, but every time the set gets called, we do technically allocate a variable here, set something to it, and then at the end of this little function, this is a mini function, this gets sort of, put out into the void. We don't have a reference to it anymore, so it'll ultimately get garbage collected. And garbage collection does cause a little bit of a hiccup in Unity. This is pretty insignificant, but it does show just a tiny little difference in optimization that you can keep track of. Again, don't break your head doing this. It's really, really, really not worth it. But yeah, it's an option there. So I don't know. Anyway, now we're in pretty good shape. Whenever a tile changes, the visuals will change automatically. Easy peasy. We don't have to randomize the tiles every 2 seconds. Let's actually like remove all that code. We'll randomize it once, because why not? Right? That still works. Everything is groovy. There we go. Yeah, we get the random tiles every run, and that'll be fine. Next time we play, we're going to want to do some sort of mouse interaction so that we can flip tiles around. Obviously, in the real game, the mouse is not going to be responsible for directly modifying tiles, but we're going to do that first just to test some things out, and it'll get us used to, hey, how do we figure out what tile is under our mouse at any given time? It would be nice to know. Also, panning the camera around. I can pan around the scene. That's great. But I would like to do the same thing in the actual game world by moving the camera. So I guess that's what we're going to tackle next time. Thanks for watching, folks. Bye-bye. Hey, thanks for watching, and thank you everyone who supports this channel via Patreon funding. You make it so that I'm able to dedicate more time towards creating more content for this channel and to continue our game programming tutorials. If you want to help support the channel, please go over to patreon.com/Quill18creates and support us today. Thank you very much.